Welcome to the second day of microXchg. Before I start, I want to say a big thank you to the organisers for inviting me. This is a non-profit conference. It's a lot of people's spare time to put this on, so I'll say a big thank you to the organisers for arranging this. It's been, I've enjoyed myself so far, and it's as good as last year, which is great. My name is Sam Newman. I'm going to talk to you a bit about microservice security. It's sort of an interesting challenge to give this talk, because I can often now assume that people have an understanding about what microservices are, but I realize that actually the average developer, of which I am definitely lower than average as a developer, doesn't actually know a lot about security sometimes. So today, I'm going to be talking about security in the context of microservices, but also trying to give a little bit of a framework for how I'm starting to try and think about security. I realized as a developer what I thought security meant wasn't really what it is. I do work at a company called ThoughtWorks. A couple of my colleagues are here. Some of you may have seen Pravina earlier give a really good talk on her experiences, and James Lewis is also here. If you want to know more about what we do, you can find either of us after the break. Let's do a little bit of audience participation. So hands up if you're a doctor. Wrong doctor. The other doctor. Hands up if you're a different type of doctor, the medical type of doctor. We have any medical doctors in the room? No, like a microbiologist? Anyone that knows anything about infectious diseases? Still no hands going up? How many of you know how important it is to wash your hands? Who hasn't got their hands up? And actually, for those of you who haven't got their hands up, where have your hands been? We do not need to be an expert in medicine. We don't need to know about the dangers of infectious diseases to know that washing our hands is a good idea. I think we're in an interesting place now around application security that a lot of us would like to think that application security is something that the experts can do for us later. In the same way as probably going back 10 years, we would, as developers, we would write the code, and then we'd have testers test the code. And that was very much a separate activity. It's sort of like we'd sprinkle on the security and the testing, sort of like icing sugar on top of a cake. The reality is you can't do that and really build secure software any more than you can just sprinkle on the testing after the fact. So rather than sprinkling on your testing and your security like icing sugar, I want you to instead think about security as laying it into the cake, kind of like cream in a Black Forest gatto. The analogies only get worse from here on out. But this is what I want you to think about. Just because you're not a security expert doesn't mean there aren't things that you can do as a developer that are the equivalent of washing your hands to keep you safe and keep your applications safe. Now, of course, this is a talk about application security, so the first thing I have to do is scare you. So how many people here have seen this before? This is an awesome site. If you ever want to look like you're really high tech, like your boss comes over and you've actually been playing Minecraft, flick over to this website and say, "What are you doing?" I'm checking out all the distributed denial of service attacks that are happening on our website. This should actually play. This is a video I capped a few months back. This is showing you real-time attacks from different parts of the world to other parts of the world. My laptop actually groans when this thing's running. You can launch it on your, if everyone launches it at once, we might trigger a distributed denial of service attack on Norse. Different times of day, you see different things going on, and those guys in the Middle East are really getting it from someone in South America. And you can watch this stuff, and it's all very interesting as who's got grudges on whom. The really interesting thing, of course, is a lot of these attack vectors are very old school. Lots of people just, doing things like flooding telnet and stuff like that. This is just the environment in which we operate. Some of this is fairly unsophisticated, albeit en masse. We exist, if you have a website that is somehow on the public internet, in a world in which we may get attacked via vectors like this. But we also have vulnerabilities that are much, much more prosaic. Now, this being a conference around microservices, I don't actually need to tell you what they are. This is the definition I like using at the moment: small autonomous services that work together, modeled around a business domain. Now, microservices actually give us some very interesting options. I think there's this phrase you've probably heard a few times already: when you buy into microservices, you are investing to get a whole load of options back. And around security, this is especially true. With a more monolithic system, you have maybe everything deployed in one process, a similar set of homogeneous infrastructure. One breach could expose all of your information, expose all of your data. You have all of your eggs quite literally in one basket. With microservices, because we have this independent deployability, because we have the ability to use different languages, to change our deployment topologies, we have the ability to provide additional protections for our eggs. So if we lose one egg, we've only lost one egg, not the whole basket. We can do things like use different segregation models. So now we're feeling good about ourselves. We can do things like apply defense in depth. We have multiple different places at which to protect our applications. And we're thinking, yeah, right now I feel pretty good. The other way to think about microservices is to think, there's a lot more surface area here. There's a lot more network boundaries that people could sniff, where people could intercept my traffic. There are a lot more machines that I've now got to look after that could be exploited. Oh, heavens forbid if I'm maybe a polyglot environment where I've got 15 different language stacks to keep track of and all to get patched. Microservices in the world of security are very much a double-edged sword, and knowing where to start can be difficult. So to start off with, I want to give you a sort of a framework that colleagues came up with at ThoughtWorks, because often what we do when we think about security is we fixate on one thing and one thing only, and that is prevention. That is stopping the bad thing from happening. And the issue is when we only think about prevention, we start fetishizing about different sorts of technology and stopping bad things from happening, and we are never prepared for what happens when something bad does occur. It's a very simple four-step model, and I think it's very useful when focusing your attention about where to spend your time, where to spend your effort. Obviously, we want to stop bad things from happening. We need to apply some prevention. We want to stop the wrong actors getting access to our data. We want to stop the bad things from happening. But when they do happen, we sort of need to know about it. Surprising how many people run all these sort of fancy security protection things. They say they patch their services, and we keep an eye on them, and it's great. And I say to them, so do you have all of your logs in one place so you can see if anything bad's happened? And they go, no. So you hope nothing bad will happen, but if it does, you're never going to know. They go, yep. So that's not good. So we need to know a bad thing has happened. That's good. We then sort of need to know how to respond. And we are blessed in the IT sector because we are surrounded by organizations that are inept at responding to security defaults, security breaches, and often show that ineptitude to us in rather humorous ways, which I'll be sharing with you. And finally, once we've found this, we've responded, and hopefully not lost our entire customer base, we need to know how to recover from these problems. So this all should reinforce. So this is the first thing I want you to think about when you're thinking about what security means, when you're thinking about baking security into your development process, into your applications. Just because you're not a security expert, you actually have things that you can do in all four of these stages to make your applications better, make your applications more secure, and make your delivery team and your organizations sort of more savvy around these sorts of issues. We will, though, start with prevention. True story. I was working at a company, and they had a newly blessed InfoSec team, information security team, and they were starting to look at access to premises. Obviously, they were concerned that people would gain access and would plug into the networks and do all kinds of nefarious things. They said, okay, so what we need to do is to stop this happening, we're going to put CCTV up to deter people from coming into our building, and also so if they do, that we can actually see them and we know what's happening. This caused uproar in the company. They said, is this really because you don't trust us? What about my privacy as an employee? There was this whole flame war that went on for a good week. It was fun to watch. Didn't want to get involved, though, about this. And then someone piped up and said, so we're going to spend a few $1,000s putting a CCTV camera on our front door. Should we maybe fix the lock on the front door first? Turned out the lock hadn't worked for a couple of years, and anybody from the street could walk in at any time. This is one of the challenges when we think about prevention. We're not always rational about where we spend our efforts and where we spend our energy. So with microservices, with all these huge, wonderful array of options, knowing where to start is challenging. There are a few good models out there that do things called threat modeling that help you think more coherently about what are the things that could affect our system, who are the malicious attackers, and how can we most cost-effectively deter those things from happening. One of the models I like the best is from Bruce Schneier. It's this idea of this thing called attack trees. This is an old Dr. Dobbs piece that's available on his website. And with an attack tree, what you do is you think about some goal that an attacker, a malicious party, is trying to achieve. So this could be accessing your credit cards, for example. Or in the example given in his paper, it is trying to open his safe. So you've got a safe installed somewhere on your premises, and the malicious attackers want to open it. So how could they do that? Well, what are the avenues they could take? They could pick the lock. They could learn the combinations. They could cut it open. Okay, these are things they could do. So with learning the combination, how might they do that? Well, they could find it written down. They could get the combination from the target. I like it when we start talking about the target, because it sounds like some sort of heist thing going on. How would you get the combo from the target? You could blackmail, threaten, and bribe them. These are interesting domains to work in when you're doing this kind of threat modeling. But actually, if you think about sort of your prize assets, doing this exercise and trying to think a little bit about this, it doesn't have to be perfect, but the exercise you go through starts opening the mind. The goal when you're thinking about prevention isn't to eliminate the possibility of one of these things happening. What it actually is for you to raise the cost of that thing happening so high that no one would want to do it. So if they have to buy a drill that costs more than the safe and the contents of the safe is worth, that might be good enough. But then what you do is you look at all these avenues and you start attaching weights. So these could be a dollar amount. How easy would it be for an attacker from a dollar amount to pick the lock? Or how hard would that process be? So maybe just a simple impossible possible. And you start thinking about this. That's really hard. Actually, you know what? Turns out finding passwords and combinations written down is really quite an easy thing to do. And then maybe you start saying, well, actually, we should spend our time making sure that we don't write passwords down, we don't write combinations down, because that's the easiest way for a malicious attacker to get access to our systems. It's interesting seeing how many organizations have password policies that are so complicated that they require you to have a password you could never remember and therefore have to have written down somewhere, thereby making your systems less secure for many domains. So this can help, and this sort of can help you start to think rationally. When we think about microservices, for example, this is an example I often use when talking about security, we have multiple different services available that have themselves different threat models. If someone cracked into our catalog service, maybe if they're very sneaky, they could poison the catalog and change the prices, but that's kind of that's not really proprietary data. We're sharing that with the outside world. Our user service, though, that's a different thing entirely. The cost, if that thing was breached, is much higher. Therefore, the amount of effort we might put into protecting it is going to be higher as well. We have to talk about the surface area. One of the first things we start thinking about in terms of preventing bad things from happening is transport security. We have exposed many more links. These links are going over networks. People can get onto your network and they can do funny things. So what do we do here? Well, we can start off with things like HTTPS everywhere. Who here uses HTTPS everywhere inside their networks? That's like 5 people, right? And this is like one of the easiest things to do, which is still saying it's quite hard. Unfortunately, most organizations I talk to that use microservices inside their own perimeters just kind of assume if you're in your perimeter, you're fine. If you've got in, it's a hive mentality. Once you get in the network, we've just got to assume you're okay, which I think is a bit naive, especially when we're in organizations where you might have things deployed into multiple different cloud vendors, going over multiple different links. But we don't do this. Now, turns out HTTPS doesn't actually give us that many guarantees. All we really know is that the server we're talking to is really the server. All we know is that the payload itself, what we get back from a server, hasn't been manipulated. And yet it doesn't actually give us by itself any client guarantees. So even if I had a server using a HTTPS-based endpoint, for example, I could still, as a malicious party on that network, talk to your service, make calls and requests, potentially, and get information. So there's no real client guarantees in this world. And certificates themselves and certificate management has still historically been a real pain. Any of you who set up even HTTPS for your own blog? It's not fun, right? Now, thankfully, a Go-based open source project has come to the rescue, which is, has anyone here heard of Let's Encrypt? There's a few, great. You should. Let's Encrypt is really important. It's basically an open source consortium that is looking to reduce the cost of, and that will make it as easy as possible to get everyone to be using HTTPS on the public internet. Firstly, the thing that I think most people fixate on is the fact that they issue root-signed certificates free. So you don't have to pay anybody. So a lot of people go, oh, that's the most interesting thing. That actually isn't the most interesting thing. The most interesting thing is the fact they've got a command line you can use for issuing and renewing certificates. This, for a microservices world, is amazing because we script our deployments. We hate anything that involves human interaction. Well, I didn't mean it like that. But we don't want to be raising tickets to get a piece of software deployed or a new machine spun up. Let's Encrypt has given us a tool, a command line interface that allows us to start automating many of these processes, and that's a huge deal. Tools like this and the Acme protocol they came up with is probably going to be adopted by other people as well, should start making it a lot easier for us to at least do that basic level of transport security within our own perimeters. We then start talking about the next level of transport security in terms of protecting our traffic while it's flowing. And then, of course, we can talk about things like client-side certificates. So now a client has a local certificate they use to sign their payloads. So now the server can confirm that, yes, this is indeed a client who I should be talking to. That's good. We like that. So somebody now getting onto your network can't just masquerade one of your legitimate clients unless, of course, they get hold of the certificate. They are a much bigger pain to manage. Anyone that's tried this normally ends up having to set up their own sort of internal signing authority and writing horrible Baroque scripts that seem to use Perl too much. Luckily, of course, Netflix is hopefully coming to the rescue. It's about time. I mean, I know they've got a business to run, but they really could have solved all these problems for us by now. They have a project called Lemur, which is very early days, which is basically their open source implementation of a public key infrastructure that should start allowing us to start automating this process as well. I've yet to hear of anyone implementing this successfully in a production environment outside Netflix, but it only came out like the end of last year. So I'm hoping to see some great case studies. So when looking at, say, our setup, our infrastructure here, when I'm traditionally thinking about something like client-side certificates, because they're a pain and often require manual work, I'll be thinking about things like client authentication outside across the public internet when talking to other services, maybe opening up API access to myself to trusted third parties. That can be a great place to use certificates, where the speed of bringing new clients online is small enough that the manual work required to get those certificates set up is justified. It's quite difficult within a perimeter where you're bringing machines up all the time to manage that stuff well. That's part of the piece. That's really authentication at the transport layer. What about things like authentication and authorization? Well, you've got the classic pieces. Okay, we've got OAuth, obviously, and then we've got OAuth 2, which confusingly isn't OAuth, the second version of OAuth, but a framework from which you can pick flows to implement a new version. It's basically OAuth 2 disappeared up its own framework. But that's a way in which you can allow things like mobile clients to authenticate themselves with public services without you having to actually give them a password. There's actually a very sensible subset of OAuth 2 called OpenID Connect that is hopefully paving the way to use OAuth-type authentication for service-to-service authentication. Most of the auth mechanisms that we use out there are sort of designed for human being authentication. Things like SAML. And technically, you can use SAML to, say, have two services talking to each other. Here, for example. It's a royal pain to do that. I have tried it. Scripting SAML handshakes for what should be, what we want to be, it's always just adding latency. That's really fun. You also have a lovely problem, a really interesting problem that you encounter far more in a microservice-oriented architecture than anywhere else, and that's a thing called the confused deputy problem. Someone did send me a GIF last time I did this presentation of a sheriff looking very confused that I promised to include in the next version of this. The confused deputy problem is a kind of an interesting class of problems in the security space. So in this world here, I log in as me on the web browser, and I use some sort of form-based authentication to say, yes, I am me. Let me access my data. And the music web shop goes, OK, yes, I've checked you, and you really are you, and here's a token, and here's all your stuff. To do what it does, to render that front page, it actually has to go and request information from a downstream service, in this example, a user service. We sort of rely on the music web shop only issuing calls that I should have access to. In other words, normally what we do is we terminate authentication here, and we assume that all traffic going through to the user service from the music web shop is sensible. We don't ever cascade the authorization. And that opens up a class of security bug where you can trick this thing into maybe asking for, I actually want to see Adrian's details. And unless we explicitly stop that happening inside our application layer, you can sort of get information from downstream services. Solving that is also very, very difficult. Ideally, what you would do is send your authentication credentials downstream to downstream services. That is achievable with SAML using nested SAML assertions. If you think normal SAML is bad, try doing nested SAML assertions. OpenID Connect, which simplifies the flows of SAML into effectively a more REST-based interface and allows you to have sort of these single grant strings which you can pass around, could open up technical solutions to the confused deputy problem. But again, I have yet to meet a single microservice organization that's properly solved this. Again, most people just hope bad things never happen, and that's not a great state of the world. That's great for transport security prevention, but we also, of course, have to think about things like data at rest. And the nice thing here is that, of course, the microservices environment, this is one area where we're often much better off because we can really target the data that is very sensitive and encrypt it where it needs to be. There's often an issue where, with database-level encryption of information, for example, where for performance reasons, you don't want to encrypt the whole database. And so you start encrypting certain tables, or you start encrypting certain columns. And then you have issues where you suddenly realize that foreign key relationships are actually leaking information. And you have to encrypt those as well. And with the large monolithic databases, can be very problematic. With a microservice-oriented system, though, you can just say, you know what, the user service is just a user service. 90% of that is stuff we don't want anyone ever seeing. We can just simplistically encrypt the whole system. The catalog service, I'm not worrying about that. If anyone gets access to it, they steal stuff that we expose publicly anyway. Who cares? That actually is, I think this is an area where this is, where microservice architectures make our lives a lot easier. I also have to say at this point, please patch your stuff. Just might be a good idea, running patches every couple of years maybe to make sure a disturbingly large amount of data breaches are caused by CVEs that have been fixed more than 18 months or 2 years ago. I saw some stats of 30% or something like that of major breaches are caused by things that were patched years and years ago. And this can be more challenging in a microservice environment because you maybe have more machines that need patching. So having systems that tell you about the gap between where your patch level should be and where it is can be quite useful. Those tools are surprisingly bad, actually. Like I tried doing this with Spacewalk from Red Hat. It's terrible. It would just randomly not tell me that patches needed to be applied when they actually did. Now, if you're cycling your machines very regularly, this maybe isn't necessarily much of a problem. For those of you doing image-based deployments and using immutable servers, this is a real challenge. You might have a service that's very stable. You've done a few mods to it like 6 months ago. Your deployment artifact is an image, and you're practicing immutable infrastructure. What happens on Patch Tuesday? What happens when shell shock, or something like shell shock happens again, or Heartbleed, and you've got to patch your whole fleet? Have you practiced that before? You really need to. If you're going to go into immutable infrastructures and tearing down images, you need to get good at that. I spoke to the REA guys, and in Australia, they use Amazon AMIs. It took them 2 weeks to cycle the whole infrastructure for Heartbleed, because the team's own deployment. So now this patch comes out, and the sort of security people are going to devs, you just need to run a new build through and get your stuff patched up. There's actually an area where people who are not doing immutable infrastructure are using things like Puppet and Chef and Ansible and actually have a bit of an edge. This is interesting. I think the tooling in this space could be a lot better for at least helping us understand where our patch levels actually are. So that's enough for prevention. I could talk for days about that, but that's the whole point of this talk, is that it's more than just prevention. Let's now talk about detection. You should start off with the really basic things. Maybe just subscribe to a few lists, like the vulnerabilities for your tech stack, know when they're coming out. That would be a good start. Using organizations like Qualys to keep an eye on the CVE, so you know when large defects turn up. When Shell Shock came out, the really interesting thing about that bug was it wasn't just the fact that shell shock happened and, oh crap, I've got to patch every Linux machine, but the nature of the shell shock exploit meant that you could look in your log files and determine if someone had used shell shock to compromise your services. That would then allow you to actually go back and say, have we been impacted by this? Have we seen signs that this has been used against us? So knowing something happened is great. Doing something as simple as aggregating your logs together in one place so you can actually see what's been happening, and keeping those for a long period of time is important. Shell shock, I think, was when it came out, was shown to cover at least a 3-year period of Linux operating systems. So that meant unless you've got like 3 years worth of logs, you won't necessarily know if you were hit by a rootkit that was using shell shock to access your systems. This is stuff we do anyway with microservices to make our systems easier to manage. It becomes very important in the security sphere. So have a think about this, but this might cause you, though, to pick different retention policies for your logs. You can, of course, use things like application firewalls. Mod security is quite well known here. These systems both do some level of prevention, but they can also help detect attacks on your system. And these things sort of sit on your crusty outer perimeter and help pick these things up. They can be quite hard to tune sometimes, but they are worth looking into. This is sometimes a place where a specialist can really help. We should also talk, when it comes to detection, about Polyglot. We are buying options. So yes, let's have lots of technology stacks because we're microservices and we need to write everything in Go, and Luau because Docker. Because Docker, Luau, Docker, go, Docker. So I have all of my Polyglot systems, and it's wonderful and amazing, and it's fantastic. First problem, now I've got a lot more tech stacks to keep on top of. I've got a lot more CVEs to look out for. I've got a lot more runtimes that need patching. And if you're not good at patching your monoglot architectures now, you're not going to be any good at patching your polyglot infrastructure, are you? The flip side, of course, with Polyglot is it can sometimes mean you've got more things that need to be broken. If your entire fleet is running Java 6, and somebody uses an exploit to crack into your Java 6 application services, then suddenly all of your Java 6 application services are vulnerable. On the other hand, if you've got 25 different tech stacks, that's 25 different exploits they might need to find. So I go backwards and forwards on this. I think for most organizations that are adopting microservices, there are enough things on your plate. And especially when you start thinking about security, I think it's a lot easier to have a smaller number of tech stacks and really keep on top of them in terms of keeping them patched and understanding how to secure them before you start going too big in terms of the different number of stacks you add. So in terms of detection, subscribe to mailing lists. Check your patch levels of your machines. Check your logs. And this will help you understand, okay, has something happened? And once you've found out has something happened, we can then move on to the fun world of public relations disasters, or response. How many people here have heard about this company, Target? Yeah, Target. Right now, Target Australia is not affiliated with Target the US. I feel like I have to say this a lot. I don't know why, but people in Target Australia really want to make it clear they've got nothing to do with Target the US, and you'll see why in a minute. Target is a very big US retailer. I think it's one of the top 5. And they were quite rare in retail in the US because they actually do have their own internal information security team. I say they were quite rare. I suspect they've all got them now. The really interesting thing was there's this team that spotted some nefarious activity. There was some kind of malware being installed on their electronic point-of-sale systems. This is not a good thing. This was a memory resident piece of malware that was sitting in the tills and they saw it being installed. And when you swiped a card, it would capture the information as it was being swiped. This wasn't capturing information out of a database. This was sitting there, hoovering up credit cards of what turned out to be a rather large proportion of the American public. And their security team said, bad stuff, they're installing stuff. Anyone? Bueller? Installing malware? No? Okay. And then they spotted that the malware was then taking all of this information and exfiltrating it back out of their networks. And they go, and they got completely and utterly ignored. That's not good. They effectively had to the only reason this got made public in the first place was partly because someone in Congress said, you kind of need to tell people about this. Their internal security team was completely and utterly ignored. They had one, but they had it in the same way as it's a token security effort. It was not plumbed into their organization. It didn't report into the CEO. It reported in quite far down in their hierarchy, and those messages were just completely and utterly lost. The CIO lost his job. I think the CEO lost their job as well. They were not fined enough. But I think it was the second or third largest breach ever in terms of numbers of customer records. And it cost an absolute fortune. It did wonders for FireEye, who actually supplied the software to Target that did pick up all of these issues. FireEye have since subsequently had their own set of PR issues. This is a great story to read about how not to handle response. Because it wasn't just the fact that they had detected but did nothing with that information. They were woeful in informing their public. And also the other retailers didn't really learn from it because we find out from the excellent Brian Krebs, Home Depot had exactly the same problem that they've discovered later on. If you want to know more about breaches, the dark web, he talks about the dark web a lot, it's very exciting, it's like CSI Cyber, you should read this blog. It's really excellent and very accessible. A big part of response is not just realizing that these messages are important, but actually being good about communication with your customers. Communication is important. Speaking of communication breakdowns, how many people have anyone heard of this website before? This was a case study in how not to do response as well. When they, this shady group claimed to have hacked Ashley Madison, they said, look, unless you shut your website down, we're going to expose all of your information. We've got all your data, we've got everything. And then Ashley Madison said, no, you don't. And then they released all this data. And they said, okay, you've only got a bit of the data, but we think it's fake. Turned out it wasn't fake. But they said, okay, it's real data, but it's only a small set of data. Turned out it was all the data. Sorry, it's all of my data, but it's just the data, and it's just the data. And the emails. It's also the data and all of our emails. Oh, okay, it's all the data and all the emails and all the source code. But that's definitely it. And this drip feed of misinformation and obfuscation just stretched out what was already a fairly salacious story over more and more news cycles. If you want an example of how to do response well, probably a good example would be to look at the Tylenol scandal I say scandal. This is a rather sad case in Chicago where a number of people were murdered by Tylenol, which is the biggest selling painkiller in the US, still is, was actually poisoned. And the people behind Tylenol, Johnson & Johnson, didn't take any chance. They said, right, okay, rather than saying, oh, it's only Chicago, they took Tylenol off the shelves everywhere in the US. It cost them $100 million, the recall. They designed tamper-proof mechanisms. They just did the right thing. And then they basically got, A, they did the right thing, and B, they got the biggest PR bump. They are still the most valued painkiller brand in the US. They got out in front of it. They did exactly the right thing. I think you've seen recent breaches in the IT space, people like Patreon, who have been very, very good, very transparent in getting out, being very clear about what's happening, being clear about the impact, and actually having a bit of empathy for the users. I can't remember if it was the adult friend finder breach or if it was the Ashley Madison breach. Adult friend finder is for a friend. Where I think the CTO came out and said, don't worry, your credit card information is safe. If you're on a site like Ashley Madison, the fact that my credit card is safe is not what I'm worried about, because I just go to my bank, I get my money back, I get a new card in a day. If my spouse, my work colleagues find out about when I like to get up into the bedroom, that's something I can't go to the bank and get sorted. So it's also about having empathy for your users. So that's sort of talking about response. The thing without that is you need to have a conversation as a company. It's not, you can't come up with a good response just after you found a security breach, because you're all running around like headless chickens going, oh crap, oh crap, oh crap, oh crap. You can't think clearly in that world, so you need to have had the conversation beforehand. What are we going to do? Not if this happens, when this happens. Talk about when this happens. What are we going to do? Who are we going to communicate with? How are we going to get it out? Who's going to be the point person? This is exactly the same way that you practice what are we going to do during a systems outage. Once you've had that conversation as a group, when the bad things happen, you can get on top of it. And bad things are probably going to happen to 75% of you. I made that figure up, but it sounds truthy, doesn't it? Let's talk now about recovery. Hopefully we've done the right things, and hopefully you said the right messages, and you've been nice to your users, but you've now got to deal with the aftermath of this situation. A lot of how you deal with recovery in this situation is kind of belt and braces sysadmin stuff. Do you have backups? It's a whole class of, data breaches and things that can do things like crypto lockers. Someone comes in and they encrypt all your database. It's a lovely little, pay us 1 million bitcoins, or we'll delete your data for lols. And they've encrypted all of your data. The data's there, and you can see it. It's very annoying. If you've got backups, of course, it's not a problem. You wipe the database out, you patch your machines, and you reload your backups from, say, a week ago. That's why having one copy of your data isn't good, because often also some people will go and poison your data. So having backups that go back a while is important. Little tip, if you're on Amazon, don't use the same Amazon account to run your production infrastructure as to look after your backups, because otherwise some malicious ex-employee gets hold of your production credentials, wipes out your production stack, and then wipes out your source code, your backups, all in one fell swoop. So keep your backups somewhere else under a different set of credentials. Because when you've got your backups done, and if you've got good infrastructure automation, which you're probably going to have with microservices, the level of automation required to deal with those numbers of machines means you're going to have to get good at this stuff. Because when the bad things happen, just burn it down. You can go and patch it, and you can hope you've really got rid of all traces of the rootkit. Some of those things are really fun, though. I mean, one of my machines got rootkitted about 15 years ago, and it was really clever because it went and patched ls and ps and all the RPM commands to hide itself. So, like, you wouldn't even know it's there. It's just sitting there nefariously in the background. If you've been attacked like this, if you get a virus on your Windows machine, who here really thinks a virus removal tool is going to help? Who here actually, when they get a virus on their Windows machine, just burns the whole thing down and starts again? I know I do. That's what you're probably going to have to do with your production services. Can you do that? This is back to that old idea of the snowflake. If you had to throw your server out of the window and rebuild it, could you? This is probably the best way to recover after a system. Get your data backed up, burn the system down, and rebuild it all. I go backwards and forwards as to whether or not this is harder with microservices. On the one hand, potentially the scope of a breach is going to be smaller. Hopefully it's been isolated to one unit. But if you've got multiple services that are all got to be burnt down, again, it comes back really to the rigor and discipline of your teams, the ability for them to react and deal with these sorts of situations. So we spoke there really about this idea of prevention, detection, response, and recovery. Application security isn't the purview of just the experts that know how everything works. Yes, there's a need for specialists in the same way that there's a need for specialist testers. But I don't think anyone in this room, I'm actually speaking for you, but I'm on stage. I don't think anyone in this room thinks that they shouldn't do any testing of their code anymore. At the same time, I don't think we can just punt security downstream. We can't just sprinkle it in like fairy dust at the end. It has to be built in to how we build and think about our systems. Equally, we shouldn't put all of our eggs in the basket of prevention. We need to think in a balanced way about all four sort of classes of issues here. This model can really help. Bad things are going to happen to you. Hopefully, you'll stop them. But if you don't, you need to be prepared. You need to at least have a conversation about what happens. The really good thing is a lot of the practices around making infrastructure easy to manage in the microservices world are going to help you deal with security breaches and security flaws. The tooling in this space is getting better. The tooling into sort of around things like Let's Encrypt and Lima hopefully are going to lower the barrier to entry to encrypting our networks, for example. The detection tools are starting to get better as well. But if anybody out there wants to write a very simple server that all it does is tell you, your patch level in your machine is this and it should be that, do you know what? That doesn't actually exist right now. So if you could build that, and that would be fantastic. I've got plenty of time for questions, which is good. It turns out my book got translated. I didn't know this, into both German and Polish. I don't like the German cover. So I suggest you buy 2 copies. And you cut the copy of one book and stick it on the other copy of the German book if you want that. I've also got a blog where I'm writing about microservices stuff. And I'm doing a new podcast called The Magpie Talk Show where I just talk to interesting people. This might be interesting to you. There's a few people I've interviewed in this room. But anyway, I've got a good sort of 5 minutes or so for questions. Question at the front here?
Hi, thanks for the talk. Arguably, CoreOS exists to solve this question of patch level. What are your opinions on that?
Well, it all comes, I mean, so CoreOS, so the comment was that CoreOS solves these problems around patching. So CoreOS, the idea is rather than having a separate package management solution, your packages are containers. It just shifts the problem. Now your images have to be secure. It does the auto-updating for you. I mean, I can do that with my, it does the auto-updating of what, though? No, it does the auto-updating of my images that themselves have to be patched. You know what I mean? 30% data point, 30% of the Docker images on Docker Hub, the trusted images on Docker Hub, have CVEs. So yeah, it's nice. It's got a tool that auto-updates the images, and I think that's a really nice, interesting idea, and I like that idea a lot. The thing you're updating still itself has to be of a sufficient patch level. And the one thing to think about with images is they tend to be a much, Docker images, is they often are a much larger collection of software than a traditional RPM is. There's often a very thin operating system in there, or if you download, I think, like the Mongo instance comes up with a 700 megabyte Ubuntu in there as well. There's a larger surface area. I'm hoping the tooling around Docker will get better for detecting issues in there, and some of the stuff around the layered file system should make that really easy, because once you've validated one layer, you can validate that layer for all images, and so that should be really efficient. So I think that it pushes the problem somewhere else, but I'm hopeful. Cautiously optimistic. I'm British. I'm never enthusiastic about anything. Okay, do you have another question? Is that in the middle there?
Sort of does go on this point is that, so if you have these immutable containers that you run and you keep them updated, suddenly it becomes the host system becomes a lot less visible for the developers. So how would you propose, well, CoreOS might be an idea, but how?
So the issue here, I guess the issue here is where you've got ownership boundaries. I mean, if you've got delivery teams that own deployment of their services, they should own making sure the things they deploy are sufficiently patched. But they're deploying onto infrastructure that's got to be managed by somebody else. So normally you'll have a platform team, somebody who manages those CoreOS instances. They themselves would also need to have some idea about that underlying, that underlying system and how that's patched. Of course, unikernel's just going to solve all problems as well. But yeah, I mean, it's a valid point. I mean, you still need to have visibility there. A good ops team, even in a world where I'm giving autonomy to my delivery team to handle deployments themselves, even in a no-ops world, which doesn't really exist, I would still expect a good ops team to be providing tools to make it easy for developers to be autonomous. I would also expect them to be doing some verification. So one of the things we've been trying to get working in ThoughtWorks is getting our infrastructure team. That's part of the reason we were playing with Spacewalk. They wanted to provide a Spacewalk server to tell our delivery teams, hey, these are the patch levels of the machines that you own, and sort of inverting that. So it's still the delivery team's job to make sure they are patched, but it's our infrastructure team's job to give the tools to help them achieve that goal. Cool. Any other questions? I've got one at the front there.
Great talk, Sam. I really like the idea of the analogy of hand washing. I've been reading recently about the checklist manifesto. The need it, say if you're doing surgery, you might need some kind of checklist to make sure this complex process, complicated process, gets followed.
The very simple thing to start with there is this the patient we're supposed to be operating on? Is it really the left leg or is it the right leg? No, it's the arm, doctor. Yeah.
Bingo. And it reduced a massive amount of problems. Do you think there's some kind of value in having perhaps a checklist for security in this context?
Well, yes, I think we do. And I think there's certainly some automated static analysis tools that can do that in an automated fashion. I saw actually, it was What If in Australia did a great case study, and they actually had a little validator. And they were adopting microservices, and they were trying to help it make it easy for developers to write good microservices. And it's had a little program that would just go and look at a microservice and list out, yeah, this looks good. Yeah, I can see the endpoints. I can see, oh, there's some problems here. And they started to build security checks into those systems. So that can definitely help. I think having a checklist, thinking about what that checklist is good. But once those but what you want to try and do, if you can, is automate the low-hanging fruit of that stuff. Not all security checks can be automated. You do need to apply some critical thinking. But it was interesting, when you look at, say, testing, and testing becoming more of a discipline that developers embrace, a lot of it was really about embracing the idea, but the tools didn't take that long to follow. The tools in the security space, and this is me channeling what security experts tell me, the tools in the security space are unbelievably awful for automation. They're mostly around ad hoc verification of things. They're based on the quarterly, the half-yearly pen test. They're not really based on integration in pipelines. There's things like the Zap Attack proxy from OWASP, which isn't bad. I think there's a Breakman, I think, does a bit of this stuff. These are all new tools. But yeah, that checklist idea, I think, is a good idea. Having a collective idea about that is useful. There's one thing that actually one of our InfoSec guys did that I really liked. Inside the TechOps teams, our delivery teams have real ownership. They're in charge of it, and we've sort of made them accountable for security. And we had this thing where before you went live, we wanted a security review of your service to say, what data are you accessing? Where is it being run? Have you thought about all these things? But that became quite onerous, and actually our InfoSec team wasn't big enough to cover all the requests coming in. And so what John had done there is he's created a checklist online, and he says, before you go live, run through these checklists. And the first thing it says is, have you read our information classification policy? And if you said yes, he, like in the background, is scoring points based on how you answer the answers. And if you get a certain score, he just says, and like some of them is, are you exposing information over the public internet? And if you say yes, that's immediately like a 200 points. And after a certain threshold, you have to have a security review. But the idea is that the checklist itself is asking you questions, which is making you think, have I thought about that? Maybe I should go and read the information classification policy. And that's kind of a nice way of using a checklist to educate at the same time. Any other questions? Okay, thanks. I can't, unfortunately, I'd love to stay for the rest of the day. I have to get a plane, and my plane was delayed by 23 hours, which I don't know was even the thing that could happen, but I'm flying home to Australia. If anyone does have any questions that they wanted to ask me afterwards, they didn't get a chance to ask me today, you can just ping me on Twitter, and I do respond. But thank you very much for your time.